We're going to do example 642. So if I'd pause the video here, go ahead and pull up the figure for 642 and draw a free body diagram of the entire truss, and then hit play again and compare your free body diagram to the one that I came up with. So here's the free body diagram. I think I got about everything. I need an X and a Y coordinate. So go ahead and look and make sure that you got all the forces, you have all the dimensions. And then what I like to do is I'll highlight, I don't remember how to highlight here. Pause for 1 second. So what I like to do is actually highlight the ones that they want us to find. So they want us to find the force in members BC. So this is member BC, HC, this one here, and HG, this one here. So now we can take a look at the truss system. We're going to need to find out external forces, and we can sort of figure out which ones we need to figure out. But it looks like we have 3 unknowns for the external forces, so we should be able to do a free body diagram of the entire system. I'm going to go ahead and make the cut first. So we can do a cut here. So it basically goes through those 3 unknown forces. And what that shows us is that we can either look at the left side of the cut or the right side of the cut. And I would say let's look at the left side of the cut. We only have the 1 unknown force, the AY, and then we have the 2 other vertical forces. So that one probably makes sense. The last reason I'm going to go ahead and do this now is just so I know that the one that I need to know, the external force, is that AY. So I'm going to still do step 1 that we went over just now, but I'm only going to be focused on finding AY. We don't need EX and EY for this problem. All right, so I'm just pasting that picture here so we can see it. So we're first going to look at the free body diagram of the entire system to determine that AY force. So if we look at the entire system and we sum the moments, let's sum the moments about point E, because we want to find that AY. That'll give us the AY. That's going to equal, here, let me pull this down so we have room. Sum the moments about point E. Let's make out of the board as positive, like we typically do. So for EY, so if we have AY times that vertical, or that perpendicular distance, so 1.5 meters plus 1.5 plus 1.5 plus 1.5, so that's 6 meters. That's going to be, if we do our right-hand rule, that'll be into the board, so negative AY times 6 meters. And then that 4 kilonewton meter, so let's go up to here, plus 4 kilonewtons, and then that perpendicular distance is the same, so times 6 meters. And then we'll go up to this next force, so we're just going around clockwise, plus 12 kilonewtons, or no, I skipped it, plus 6 kilonewtons. Six kilonewtons times that perpendicular distance, which would be 4.5 meters. That's this distance here. Plus, just using the right-hand rule, 12 kilonewtons, so that's this one here, times, and that perpendicular distance is 3 meters, plus 9 kilonewtons times 1.5 meters, that's this one. And then the ones, the 6 kilonewton and the EX and EY are all at point E, so there's no perpendicular distance. So we don't have to include those, and those all equal 0. So now just take a second with your calculator and calculate that out. I'm going to pause it while you do that. Alright, so I just did the calculation in my calculator, and I got AY equals 16.75 kilonewtons. And so, since I got a positive number, that means that we were correct in assuming AY was up. And since we're just looking at that left side of the cut, we don't need to find EX and EY, so we're just going to skip that for this one. If you were to find it, there wouldn't be anything wrong with that. It's just not needed. So that was steps 1 and 2, basically. Now we need to get to step 3. So step 3 was decide on how you need to cut the truss. So we did that early. Step 4, draw a free body diagram of the selected part of the cut truss. So let's do that now. So we're just looking at that left-hand side. So let's draw. So we have A, we have H, B, we have that force HG that's not known, HC, and BC. And then we have that AY that we just found, which is 16.75 kilonewtons. Oh. And then we have that 4 kilonewton force coming down. And we have a 6 kilonewton force coming down at point H. And there's a link between H and B. And if we look at the free body diagram here, we can also find a zero force member. So see if you can identify that. Basically, it would be this one here. So HB would be 0. It's not one we need to find, but just start trying to keep an eye out for those things. I'm going to write the units or the dimensions in here. It's 1.5 meters from A to B. The height from H to B, so the height there was 1 meter. And I think that's it. So what we want to find is the HG, HC, and BC. So we have 3 unknowns, and we have 3 equations, so we should be able to deal with that. So let's do, and I'm going to go ahead and do my X and Y axis. So now we have 3 equations and 3 unknowns, so we need to apply those equations of equilibrium to the problem. And this is step 5, so this is the final step. So we can sum the moments about a certain point, and usually you pick the point that you have the most, the most unknowns about. So we have HG and HC are 2 forces at point H, so I'm going to do the moment about point H equals 0. So the sum of the moments about H, so we have the force, let's just go in a clockwise direction, so we have force BC, that's times that perpendicular distance times 1 meter, and BC as currently is drawn is positive, and we're doing positive is out of the board, so BC times 1 meter, then we have that 16.75 kilonewton force, and the perpendicular distance to that from point H is 1.5 meters. And then the direction of it, so if we do the right-hand rule from H down to A and do our fingers in the direction of the force, it's into the board, so that'll be a negative moment that it produces. And then we have the 4 kilonewton force, so plus 4 kilonewtons. So that one, if you do the right-hand rule, you're going to see it's coming out of the board, so it'll be positive. So 4 kilonewtons times that perpendicular distance, which is at 1.5 meters. And then we go back around and we're up to point H, and those don't have any moment arms, so they won't create any moment, so that equals 0. So now we can find BC. So I'm going to pause it. Go ahead and pause here and y'all can calculate. Alright, so I calculated it out with my calculator, and I got BC equals 19.1 kilonewtons. So now we have one of the things that we need. And since I got a positive number, it means I was correct, and it actually is to the right. And actually, instead of, we could draw an arrow to the right, which would work, but let's say if it's in tension or compression. Yeah, that's what they asked for in the problem statement. So if it's pulling away from point B, that would mean that it was actually in tension. So we'll do a little T there. So now our other formulas, we can sum the forces in the x direction is equal to 0 and sum the forces in the y direction is equal to 0. I'm going to select it and move it to the next page just so we can see what we're doing. So now we have some other equations. We can sum the forces in the x direction equals 0 and sum the forces in the y direction equal to 0. So I'm going to start with sum of the forces in the y direction equal to 0. It looks like I didn't, which I should have actually put all the dimensions on here, or on this. So HG, so from H to G is 1.5 millimeters to the right and 1 meter up. So that would be 3 to the right and 2 up, just for the, let's see, just to make it even numbers, 3, 2, and then that hypotenuse would be the square root of 3 squared plus 2 squared, so that would be 9 plus 4, so square root of 13. And then for HC, it's also similar. It's over 1.5 and down 1, so that would be 2 and over 3, and then that hypotenuse would also be the square root of 13. So sum of the forces in the y direction, we get 16.75 kilonewtons minus 4 kilonewtons minus 6 kilonewtons plus that y component of Hg, which would be 2 over the square root of 13, then minus that y component of Hc, which would be 2 over the square root of 13, and then BC is just horizontal, so that doesn't count. Set that equal to 0. So now we can have Hg in terms of Hc, so I'm going to pause it and calculate that. So that gives us 6.75 kilonewtons plus 2 over the square root of 13 Hg minus 2 over the square root of 13 Hc equals 0. So we'll just solve in terms of 1. Hg equals 2 over the square root of 13 Hc minus 6.75 kilonewtons. And that would be all times the square root of 13 over 2. So Hg equals Hc minus 6.75 times the square root of 13 divided by 2, which would be 12.169 kilonewtons. So that'll be a helpful equation. And then let's sum the forces in the x direction. When we do that, we get, so the 16.75 is in the y direction, 4 and 6 are all in the y direction. So we just need the x component of Hg, which would be 3 over the square root of 13 times Hg, plus Hc, which is 3 over the square root of 13 Hc, plus Bc, which we solved, was 19.1 kilonewtons. That equals 0. It looks like I probably have a sign wrong because they're all going to the right, but that's okay. We'll just get a negative value for one of them. So what I'm going to do is I'm going to take that formula for Hg and I'm going to put it into here so we can solve for Hc. So that'd be 3 over the square root of 13 times Hc minus 12.169 kilonewtons plus 3 over the square root of 13 Hc plus 19.1 kilonewtons equals 0. So now we can solve for Hc. I'm going to pause it and do the calculation, and y'all can also. Alright, so I calculated it out, and I got Hc equals negative 5.39 kilonewtons. So that means that we guessed the direction wrong, so Hc equals 5.39 kilonewtons, and that would be, we had thought it was in, or we put it in tension, so it's actually in compression. So now we have Hc, and we have Bc. Now we just need Hg, and we have this equation here. So let's put that into the equation. Let's see, we get Hg equals Hc, which is negative 5.39 kilonewtons. And the reason I put the negative is because we had assumed the other direction when we wrote the equation. So we need to have that negative sign, minus 12.169 kilonewtons. So we get Hg equals negative 17.6 kilonewtons. So we also guessed the wrong direction for Hg. So that means that Hg is not in tension, but it's actually in compression. So Hg equals 17.6 kilonewtons, and that's in compression. So you see, if you guess the direction wrong, it's really not a big deal. You just have to remember to follow that through for the compression. And that's it for that. So for homework, or for what you need to do for the rest of the class, is work on problems 628 and 641. The other homework problem is 632, and that one has a video available online as a resource, and those are due October 3rd. And I hope class goes well, and I'll see you all on Tuesday. Thanks.